I'm really pleased to be back with you here today to provide you with an update on the research that we're doing there at the NCAT Pavement Test Track. Of course, we've started our track in the late 90s. That compares to mid-90s with the Min Road facility. So we kind of have our histories have sort of tracked along a similar path, and we were very pleased to be able to engage in a partnership with Min Road because we've collaborated informally for a very long time. Well, beginning in 2012, we started building test sections off of our track. Our track is an accelerated test facility where we compress a design lifetime of damage into about 2 years of fleet operations that, they're sort of in the middle of our 3-year project cycles. In around 2011, we started pitching the idea of doing pavement preservation research. And that's because we're a pool fund. We're sponsored completely by state DOTs and by FHWA and by some private sector partners like FP2 now. And so we don't, we try to do research that directly meets the research needs of our state sponsors. So 2010, 2011, pavement preservation was becoming a huge need for state DOTs because of the increasing cost of conventional practices and dwindling tax resources. So FP2 and NCAT kind of came together in this really productive partnership. FP2 helped us to develop a game plan to do some preservation research on the track, but then research off the track. That's how Lee Road 159 came about. We found a dead-end access road to a quarry and an asphalt plant, and we mapped all of our pretreatment distresses, and then a task group with FP2 helped us to figure out what are the right treatments and the treatment combinations to put on all these test cells inbound and outbound lane that we have on this road. Well, that lined up with our 2012 track build, which allowed us to do cold recycle as part of the work we were doing on 159, which I'll explain in just a minute. But based on what we learned from Lee Road 159, we wanted to expand the research, again, in partnership with FP2 and do some high traffic pavement preservation. So that's when we moved a few miles over and we did pavement preservation test sections on US 280, which was a high traffic roadway. So we've got accelerated traffic preservation on the track, low traffic preservation on this quarry road, Lee Road 159, and then high traffic preservation out on US 280. Well, the US 280 research came about in our 2015 research cycle, which was also our official starting point for our partnership in preservation and hot mix asphalt mix performance testing with the Minnesota Road Research Project. So we're very proud of the relationship that we have with them and excited to give you an update today on the work that we're doing on the track 159 and 280, and then in conjunction with Min Road. And I think it's going to fit together well with Ben's talk and with Jerry's talk. I don't think we have any redundant information, so hopefully you'll find it useful. So we're a national transportation pool fund. We're actually the largest national transportation pool fund. They tell me that FHWA has been the banker for, and it's the mechanism that allows state research dollars to flow into Alabama DOT, who manages our pool fund, and then we in turn are reimbursed for project expenses. When we started the test track back in the late 90s, we had 8 state DOTs that supported our research. We grew gradually through the years, but because of the partnership with Min Road, now we currently stand at 19 states. It's possible we could be 20 states when we start the cycle next summer. So the partnership, that's all possible because of the partnership with Min Road. So those northern tier states that you've seen mentioned in the previous presentations, because of the concern for thermal cracking, you don't feel too good about going into the deep south to do test sections, but you feel pretty good about doing direct comparison sections that are placed in the north. We're also really pleased to report that Texas DOT has gotten back on the track. They got off the track after the 2006 research cycle, and they're the first states to sign up for our next track build, which will occur next summer. And of course, your connection to us, the connection of the industry to us, is through FP2. FP2 is a full funding partner with the state DOTs, and kind of like our National Transportation Pool Fund is our mechanism for all the states to send resources to NCAT and to Min Road for the project. FP2 it's sort of like a little pool fund, and it's a way for the industry to provide resources and to get plugged in as well. So we're proud of the great relationship that we have with our friends at FP2 and the affiliated companies and organizations like ARRA. So if you look at the mission statement, and I look back at the presentation that I made at last year's meeting that we were very, very pleased to host there at Auburn University and at NCAT, and kind of look at the mission statement, what you do to promote recycling and preserve resources and to do it in a strategic way. The research that we're doing, the practical research that we're doing through the NCAT and Menroad partnership, I think is perfectly aligned with your strategy here with ARRA. So last presentation I made last fall, I went back through all the history that we've done at the track with recycling, high recycle content mixes, and then cold recycle and preservation. I'm not going to go back with the time that I have and kind of beat all those things up again. What I wanted to do strategically was use the time that I have to bring you up to date on what has happened since last year. So I'm going to start with the 2012 work that we did with cold recycle mixes, and then also the work on Lee Road 159, which kind of went hand in hand with that. The cold recycle that we did on US 280 in 2015, which was in-place recycling and central plant recycling, and then kind of end up with 159 and US 280, County Road 8, and US 169 up here in Minnesota. So all of our experience with cold recycle mix goes back to the 2012 research cycle. Where's Brian Diefendorfer at? I know he's in the room somewhere. Okay, well, Virginia DOT came to us and said, hey, we've done this work on I-81 with cold recycle base mixes, but we want to do some structural research with instrumented pavement so that we can quantify the contribution of FDR foundation and cold recycle mix to know how thick overlays need to be on these mixes when you put them in high traffic pavements. So we did 3 test sections for them in 2012 with cold recycle mix. The buildup that you see in this graphic is the passing lane on their I-81 project that they did back years ago. That was 5 inches of cold recycle mix, central plant mix with a 4-inch asphalt overlay. The truck lane was completely failed on this project, so they went in and milled off the asphalt, hauled it back to the plant, did FDR on the base and the top of the subgrade, and they left, I think, maybe an inch of asphalt on top of that to provide a work platform. Haul that material back to the plant. So the cold recycle mix in the passing lane was in place. The cold recycle mix in the truck lane, since it was completely failed and required a structural approach, that was central plant done, and then both of those sections, the truck lane and the passing lane, had 4 inches of asphalt on top of them. And when we first started communicating about this with Virginia, I was really impressed with this, to me it was one of the most progressive things that I'd ever seen a state DOT do, because it was so targeted. It's like, sometimes we're not real good at engineering our projects, and to me this felt like this project was highly engineered and it had an excellent approach. So what we did was we built these 2 sections and we put strain gauges and pressure plates in them so that we could see how the pavement was responding to passing loads and then subject it to accelerated traffic. A 3rd section we did a 6-inch asphalt overlay on, and that was really because using this accelerated testing approach that we have at the track, where we do 10 million equivalent single axle loadings in 2 years of fleet operations, we really didn't know how quickly we would fail 4 inches of asphalt directly on top of these cold recycle sections. So this is what we've learned, and I'm not going to go deep into this. This is the only slide that I have about this, because Brian is going to talk about this in greater detail when he speaks later. But this graph is a plot of the bending that we measure on the bottom of the cold recycle layers in these 3 test sections. So that the black line in the middle historically is kind of the break point between what is a perpetual pavement that will never crack from the bottom up on the left, and then what is not a perpetual pavement and is going to crack from the bottom up on the right. That line, for hot mix asphalt, we've seen that over and over and over. Richard Willis, who now is with Napa, this was actually part of his dissertation when he was at Auburn University and worked at NCAT. So you can see that the test section we did for Virginia that has the FDR foundation well on the left side of that line. You know, every hot mix type expectation that we have is that's going to be a perpetual pavement. But then the other two sections that are on the cold recycle base, they don't look perpetual based on the hot mix approach that we have to the strain measurements at the bottom of the pavement. And this is a cumulative distribution curve if you're interested in that type of thing. The main point here is we don't think, based on what we're seeing, that the cold recycle mix from a fracture mechanics point of view at the bottom of the pavement, we don't think it's behaving like a hot mix asphalt. So it's kind of like, if you think about cold recycle mix, you know, a lot of us will say, well, in some ways it behaves like a granular base, and in some ways it behaves like a hot mix asphalt. Well, you kind of get sort of it's potentially the best of both worlds, because doesn't appear that it's going to fracture like hot mix at the bottom of the pavement would fracture. Maybe it's a little more forgiving from a fracture mechanics point of view, like a crushed aggregate base would be. So we're going to, we think, extend traffic on the thinner sections, the 4-inch overlay sections for Virginia in our next research cycle, because we're approaching 20 million equivalent single axle loadings on these pavements. And then the fourth section with 6 inches of asphalt as an overlay, we do think that it's perpetual, and that we think we're going to be able to do a rejuvenator dense mix inlay in that section, so we can keep the cold recycle base layer in service, and at the same time learn something about balanced mix design in a rejuvenator mix in an inlay. So we're really excited about that, and you know, nothing but positive experience with cold recycle material going all the way back to the 2012 track. Well, as I said, we were building Lee Road 159 at the same time, so it turned out to be a great opportunity using RAP that was actually from the I-81 project that we had hauled down from Virginia. We had enough of that mix going at the time that we were able to do a mill and inlay on the part of Lee Road 159 with a thin asphalt overlay. This was a really important foundational step for us, because kind of what you know, this was, again, 2012 was our first adventure in cold recycle mix, and what we were told was, well, you want to put it deep enough in the pavement structure so that it won't create a rutting problem and a roughness problem under traffic. Well, on Lee Road 159, we thought, well, this mix looks incredibly stable. We think it's a great mix design provided by Virginia DOT to us. It was a foamed asphalt mix design. So we thought, well, let's push the envelope on 159, because if we blow test sections out there, we can fix it, and it's not a big loss like it would be potentially out on an open roadway. So we just put a 3/4 inch thin overlay on top of cold recycle inlay, about a 5-inch plus or minus cold recycle inlay. Good place to do that, because, you know, like I said, if it failed, then we could handle that. Well, if you look at the traffic that's been applied to Lee Road 159, and these are numbers as I stand up here today, we've got 70,000 easels on the inbound lane, and again, these sections were all built in 2012, so they're over 5 years old. And if you want to kind of put that on a scale that means something, I think Ben mentioned the traffic that's applied on the low volume loop at Min Road, the inside lane by Doug the truck driver. I think the easel rate on the inbound lane on 159 is approximately equal to what Doug does on the inside lane of the Min Road low volume loop, which is kind of a neat connection to make between the two facilities. Of course, we got empty trucks going in, they're loading up at the quarry and the asphalt plant, and they're hauling full out when they leave. So we're approaching 800,000 easels in the outbound lane, in the more heavily loaded outbound lane on Lee Road 159. Same treatments on both sides, so we got some diversity in pre-treatment condition and some diversity in performance that's fueling the research because of how the inbound lane compares to the outbound lane. And again, all these sections were done in the summer of 2012. Here's a picture of the one section where we removed the pavement structure. Everything else on Lee Road 159, all we did was broom it, tack it, and apply the treatments. Chip seal, microsurface combinations and capes, crack sealing, fog sealing, thin lays of different types. So we took one of our test sections that was in the middle of the thin lay group that we put on the south end of Lee Road 159, and we milled out the existing pavement structure. We put in our cold recycle mix, and then we just put a 3/4 inch thin lay on top of it. And that turned out to be a really important step for the future for us, because just with the 3/4 inch thin lay, performance has been outstanding. This is a bar graph of cracking performance the percentage of the total lane area that's cracked on just on our thin lay sections on the south end of Lee Road 159. And what we're doing with our pavement preservation data is kind of looking at it through the lens of the MAP 21 performance criteria. So if you look at cracking, you've got fair cracking condition when it's between 5 and 20% of the total lane area that's cracked. So the three sections on 159 that are the thin lay sections that are into the fair range now, and these are sections that had a pretty extensive amount of fatigue cracking in the outside wheel path when these treatments were installed. One of them is a ultra thin bonded section where we had some moisture conditions that caused some debonding and some slippage in the outside wheel path. And then the other two elevated bars there, one of them is 54% binder replacement from wrap and 19% binder replacement from shingles. So the sections that we loaded up with recycled materials, we now have cracking up in the MAP 21 fair range, but everything else is in the good range, and the bar that I've got labeled L20, that's section 20 on Lee Road 159, that's the section that we put the cold recycle mix in, really not as a base layer that we kind of buried, but more like a base binder layer because it's just got a 3/4 inch thin lay on top of it. So excellent performance, zero rutting in that section, no rutting in that section, and very, very small amount of low severity cracking. Now the approach that we're taking, this MAP 21 approach, this is something that's been developed since we had the meeting last fall at NCAT. Dr. Adriana Vargas is our PI now on this experiment. And so she came, we had this philosophy of, well, we're going to relate everything back to varying levels of pretreatment condition. So she took the sections that we have 100 feet long, 2 lanes wide, that are broken up into 40 subsections with a great amount of diversity of pretreatment condition. She said, okay, we're going to track the data separately for the pretreatment subsections that fall into the MAP 21 good range, MAP 21 fair range, and MAP 21 poor range, and we're going to see how much life-extending benefit we get when we band the data that way. So this is real data from Lee Road 159 I think it's for the chip seal section. So you can see that with the chip seal, when pre-treatment it was good, we've got 5 years of performance with a chip seal where it's still good under traffic on Lee Road 159. The fair and the poor pre-treatment subsections, they return to fair and poor pretty quickly, but we're still getting some good performance out of that. So another way to look at the poor curve that I just showed you is when these subsections in the chip seal section, in this case, when we applied the chip seal, single layer chip seal to this, even though they were in the poor range, MAP 21 poor before we started, we got 3 years of performance in the good range. We got 5 years of performance in the fair range, and then beyond 5 years, we were back into the poor range. This is just for cracking data. The other two MAP 21 parameters for flexible pavements are roughness and for rutting. Roughness and rutting is good on all of our sections on Lee Road 159, so we're really focusing on the kind of the cracking window in the data. But this is the type of an analysis methodology that we're using now on our southern low and high traffic roads, and now the northern low and high traffic roadways that have been built up here. So US 280, of course, US 280 preservation sections are 1/10 of a mile long just in the westbound truck lane, just a few miles from the test track. They were placed in 2015, so they're a little over 2 years old now. Well, since they were placed, just that lane has seen 4.4 million vehicles, and that amounts to about 1.3 million easels. So in the little over 2 years since they were placed, they've supported a lot of traffic out there. The one section that I wanted to invest time in mentioning to you today, everything, first of all, has done really well out on 280. We don't have any sections out there like 159. There's no bad performers. We've got just kind of different levels of good performance with the treatments that have been applied. What I want to focus on is the 4 sections that we built with cold recycle. We kind of built them like we built that one section on Lee Road 159 where we milled out. We put really cold recycle binder mix in, and then we put a thin lay on top of it. Now, in the case of 280, because of the really high traffic level, we made the decision, well, let's go just a little bit thicker, put a 1-inch thin lay, 475 thin lay on top of it. So we've got 2 central plant sections and 2 in-place sections. that are kind of side by side. And then for the central plant and the in-place, one of them is a foam and one of them is emulsion, kind of like what they did with test sections up here at the Minroad facility. As you can see, these cores were cut just a couple of months after the sections were built, and you really couldn't distinguish between the central plant and the in-place and the foam and the emulsion after a few months of service. In the heat of service in the southeast, they all look the same. Main point here is no rutting, no cracking, no increase in roughness, and that's with a lot of easels and over 2 years of high traffic out on 280. So we've got excellent performance, again, with coal recycle mix, and it's not been buried in the pavement. We've got it pretty close to the top of the pavement, but performance has been nothing but positive so far from in-place and central plant with both foam and emulsion. So that brings us to the Minroad and to the test sections that we did in partnership with Minroad. And I can't really brag enough about the team up here. Y'all were gracious and let me come up here last summer 2016, and be involved in the construction activities of the mainline sections that are part of our national high mix asphalt mix performance test experiment that Ben mentioned. A big diversity of mixes that we expect to crack at different points in time there on the main line. And we've also got some select preservation sections that we did on the low volume loop. But the big features is County State 8 Highway 8, what we would call County Road 8, there in Pease, Minnesota, just on the south side of Malacca, and then adjacent to that, US 169. So we've done the same thing up here that we did at NCAT. We've got kind of just a handful of sections that we've built on our track, and then we've got off-track test sections and low-traffic application and high-traffic applications, and we've got the same sets of test sections that we've now built at the 4 installations where we're monitoring performance with the same vans as Ben mentioned, and all the data is going into a common database so that we can quantify the life-extending benefits. So the test sections, the preservation sections, I don't think the plan is for y'all to get to see those because they're 45 minutes to an hour north of the Minroad facility, but they are, like our sections, it's an open roadway if you get the opportunity to see these sections up. They're built there in Pease, Minnesota, on the south side of Malacca, where the high traffic sections are on US 169 in the northern truck lane. The low traffic sections are on County Road 8, which runs right off of US 169 there in the little community of Pease. If you look at the traffic levels, and this is based on data that Jerry provided to me, I think it's 2014 data, traffic numbers that we have that we're sharing publicly as we go through the process of breaking everything down into easels. County Road 8 is a little over 700 ADT, but it's 8% what they classify as heavy commercial, and this is because of the farming community, all the farming equipment that runs up and down this road. So we've got quarry and asphalt paver equipment on our county road where they got farming equipment here. And then US 169 is over 16,000 ADT with 3% heavy commercial. So the traffic ranges are similar for low traffic and high traffic that we have down in the southern test section. So we're collecting our van data on all 4 locations. Ben and I, we had a sponsor meeting up here last month, and we went out and took pictures of all the test sections. This is a picture of him collecting some headlight information using the iPad system that we both use. And this happens to be a scrub cape on County Road 8. And I like this picture because it's an action picture of my good friend Ben out there hard at work collecting data on our test sections. But also this is one of those thermal cracks that they've been talking about up here. And County Road 8, we only treated 1 lane, and the sections are 1/10 of a mile long. But what's neat about it is you can look in the opposite lane and see the severity level of the thermal crack that extends all the way across that lane from shoulder to shoulder. And then in the pictures that we were taking that day, you can see how the treatment influences that thermal crack and how it at different levels of severity of reflection. So this is a microsurface on top of a scrub seal. We've had a lot of success with scrub seals in South, and we've seen good performance in combination up here with the scrub seal as well. Moving over to US 169, US 169 is different because it's divided 4-lane. Test sections are 1/10 of a mile long in the truck lane, and in the passing lane, Minnesota DOT came back and put the same microsurface all the way down in the passing lane. So when you're standing on the shoulder taking pictures like we were, you can't see a treatment in the right lane and then sort of the control in the left-hand lane. It's a different situation because it's been covered up with microsurface. So we have standalone control sections. And the day that Ben and I went out and took all these pictures, we stopped at the third thermal crack in every test section on County Road 8 and on US 169 so that we can go back over time and take pictures at those same locations and have a nice kind of moving picture view of how pavement condition is changing. So you can see this is a control section, a thermal crack in a control section on 169, and you can kind of see the level of raveling that is there, kind of the weather deterioration is there, and those are some pretty aggressive thermal cracks really on both of those roads, on County Road 8 and on US 169. So this is a picture of the 20% aged binder thin lay that we did on 169, 3/4 of an inch thick, and it's 20% aged binder from fine fractionated wrap and from shingles. So we ran these mixes, I think, with 11% fine fractionated wrap and 3% processed shingles and a 4.75 dense graded thin lay mix. And as you can see, we've got a reflection of the thermal crack. Every test section on County Road 8 and 169 has at least some of the thermal cracking that has reflected. So there's not a single section out there that doesn't have at least some thermal cracking reflection. So this is a very aggressive test environment, and the way we're breaking these sections down into subsections is really, really important because we got a lot of pavement surface area that has no cracking, but then these thermal cracks fall into subsections where there's a significant amount of the total lane area that's cracked, and then that's how we're monitoring the data by breaking down into this subsection approach. So kind of where does that leave us to provide you with a summary of everything? Cold recycle, our experience has proven cold recycle has a really high non-surface potential, and I'm not just going to limit it to base as we've done in the past. I think depending on your roadway, it's got some binder applications because we've seen good binder mix performance on 159 and on 280. So I think we've got some good applications across the board in non-surface. We got quality treatments at both locations with verification testing. This is a really important thing because I think, as Ben mentioned, we used the same placement contractors up here that we used in Alabama, which was a unique opportunity to have really good experimental control. But we used a rigorous kind of QC/QA testing process at both locations for all of our treatments that gave us the quality that we were looking for. So we did rate verifications on the emulsions and the chips. We did chute samples on our microsurface with pretty extensive laboratory testing that we now have as a proposed standard test procedure. We really had a rigorous testing plan, had good contractors to work with, and a good inspection team with the DOT in both locations, and we hit all of our quality targets. So when you see the good performance that we've had from all of our preservation treatments, including the cold recycle mixes, it's because we were able to test it in a really rigorous way. And there are people who think, oh, well, you can't test some of these treatments as rigorously as you test hot mix asphalt. Well, that's not true. I mean, you can. You just got to have the right testing program in place and have an educated inspection team that's committed to doing the job properly. We are viewing all this data through the lens of MAP 21 for cracking and for rutting and for roughness. That process is developing really nicely. All the northern sections have reflected thermal cracks, as I mentioned. We do have snowplow damage on the chip seals that we placed up here, and you can see where we've knocked some material off with a snowplow blade, and that really was expected when we got into this. Aside from the snowplow damage, in my opinion, we're seeing similar trends between the southern sections and the northern sections, and that really applies to the low traffic roadways and the high traffic roadways, which I really had no idea what to expect going into this and how things would be different. But I think that the curves are going to look very similar to the life extending benefit curves when we finally have everything all drawn out. One of the things that's consistent from location to location is I think we're going to need to use reduced emulsion rates in the high-traffic multi-chip treatments. In both locations, we're seeing nice-looking performance on the low-traffic roadways, but some bleeding and some flushing in the high-traffic roadways. And I think we're going to need to back off on the emulsion rates for the chip designs in order to make that successful. And we've seen in both locations really good performance from the combination treatments and from the thin lays. So I think there's just a good story across the board with all of our preservation treatments in both locations. Now, where we are currently is we're sort of evolving our project into our next research cycle at NCAT, and the two joint projects that we have with Minroad, the cracking group and the preservation group, the cracking group is still going to be done underneath the NCAT umbrella, and the preservation group is going to be done under the Minroad umbrella. So we're going to kind of have a two-way relationship with our friends up here at Minroad, and the cost to participate in both of these studies goes down dramatically because we've built the sections. Now we're in the long-term data collection, and we think we're going to be collecting data from these sections for a very long time. So we're doing a lot of traveling, talking to a lot of multi-state groups, because we really hope that the relatively low cost to get involved in this is going to be a big appeal to get more states on board. If we end up with big state participation and then we have the resources to build some additional sections, we have space up here and then we have space at NCAT to build some new sections. And if we end up with the resources, the financial resources to do that, then hopefully in the future we can report on adding test sections of different types to both locations. If you're taking notes, the cost to participate in the preservation group in the last cycle was $120,000 a year. The cost in this cycle is $50,000 a year, so that makes it something that's very attainable for a lot of states when you look at the research dollars that they invest. The cracking group cost was $210,000 a year in the previous cycle. It's $100,000 a year in this cycle. So you got now a window of opportunity for states to get on board. For $150,000 a year, they can get plugged into both experiments and have an oversight capacity in both of those. Well, unfortunately, our test track conference, our end of cycle conference that'll include research at NCAT and at Minroad, it has a bit of a conflict with the next conference in France. Ours is March the 27th through the 29th of next year. So I'm not encouraging any kind of competition with our friends in France. But if you happen to not be going to the conference in France, you might want to think about coming to the NCAT track and participating in our program there and doing tours of the low traffic and the high traffic roadways and the test track. I don't know if I have time for any questions or not. Anybody got any questions? Ben has called me out. I got to have one question. So. Yes, sir. Mm-hmm. We did use cement for the emulsion designs and for the foam designs. I think it was 1.5% cement for both of those designs. It was either 1% or 1.5% cement. And for the in place, we had we got a local contractor who's doing a lot of FDR work for the counties, and so he came out with his calibrated cement spreader, and we placed it prior to going in and doing the downcut milling to do the in-place recycling. So we were really pleased with the way it all worked out from a quality and proportioning point of view. And I got to think there's a lot of companies, in addition to the financial support from the states, that supported what we've done. Vertgen was great to help us with the central plan and the in-place work that we did on 280, and Road Tech has been amazing also. They mobilized to support our milling and our paving down south and up north when we came up here. So and there are a lot of other companies I couldn't get into mentioning, but we appreciate the support from industry that comes to us in a lot of different ways.